Hi, everyone. The last thing I want to look at for thinking about the derivative as its own function is probably going to be the most challenging. It's going to be looking at a graph of a function and trying to draw a rough sketch of the graph of its derivative. This is like mental gymnastics a little bit. It's challenging. It's also one of those hard things that will genuinely make you smarter if you really think about it and work hard at it. You'll make new connections. So I'll walk through all of these, but I encourage you at any point to stop the video and try and draw your own and then check yourself. I think that'll be the most helpful way to work on trying to learn something that's fairly tricky. So this is my function number one that I'll work on. I like to start right away for looking for discontinuities or flat spots. And by flat spots, I mean anywhere where the tangent line will be horizontal. So local maximums and minimums are good places to look. What I love about those is that at that point, I know that f prime is equal to 0. Which means on the graph down below where I'm drawing f prime, my y value will be 0. So I'm going to follow this down and say, okay, right here, my y value is 0. So what's really happening when we sketch the derivative is we're taking the slopes of our function and we're turning them into the y values for the derivative function. And that's how it works, right? The function inputs x's, outputs y's. The derivative inputs x's, outputs slopes. But still, the output will show up as a y value on its graph. I can make some fairly good broad statements in between. Anywhere, I'm going to color code this a little bit, anywhere along here, if I draw a tangent line, so say right here, its slope will be positive. So on this graph down below, that means that, so positive slopes all the way along here, that means that my y's should be positive. I should be somewhere up here above the x-axis. The next section, let's see, right here, I can say the opposite. So anywhere along here that I draw a tangent line, my slope is going to be negative. So all through here, I expect my y values to be negative. And then the last section, again, my slopes are positive, which means my y values should be positive. So this is actually a fairly good start. We know when the derivative graph crosses the x-axis. We also know when it's above and below the x-axis. From here, try to get it even a little bit more detailed. So as I work my way along this curve, I'm just going to go left to right. I start with, talk about your slopes, I start with fairly big slopes, and those slopes are getting smaller as I go. The tangent line's flattening out until I hit the maximum where my slope is 0. I now want to take that down below and say I start with fairly big positive y values, and those y values are getting smaller as I go, and then they hit 0. So that's, again, very rough, but it's just the beginnings. We're going to get some cheats that'll help us do even better as we go learn more about derivatives. For this middle section, I start with a slope of 0, and then they start to get a very little bit negative. Somewhere in here, I get the steepest negative. It's still not very steep, but it's definitely the steepest negative. And then they start to get flatter again until my slope is 0. So on the graph down below, my y values are 0, and then they start to get a little bit negative, and they get a little bit more, and somewhere in the middle, we get the most negative y value, and then they start to get a little bit closer to 0. The y values get, oh, it's harder to say bigger or smaller there, closer to 0. I'll stick with that. And then we finally hit 0. For this last chunk, I start off with a slope of 0. My slopes become small positive numbers. That's my tangent line. As I move over, they become bigger slopes. And then out here at the end, if I imagine a tangent line, its slope is even bigger positive. So now as I move down below, I'm going to start at 0. I'm going to get small positive y values. As I go, they're going to get a little bigger and even bigger. So this is very rough. Let me erase out my shading so that you can see. And all of that put together, ignore the fact that I color coded for positive and negative, all of that put together is a rough sketch of my derivative. Is it perfect? Absolutely not, but it's a decent rough sketch. If you're really getting stuck, you can even draw in some tangent lines and estimate their slopes. So for example, right here, since I only want rough sketch, you certainly don't need to do this all the time, but right about here, if I drew in my tangent line, let's see. Okay, that's rough, but it's okay. And I wanted to find its slope. There's not even a scale labeled here, but I do have boxes. So it looks like I would go over 3 down 2. So that would be a slope of negative 2/3, assuming each box is 1 unit, which means right about here, my y value should be negative 2/3. Again, I don't even have a scale. So if we're assuming that each box is 1 unit, I'm a little low. I'm closer to -1, but I'm in the ballpark, right? And you could do the same thing out here. You could draw a tangent line for this point, and it looks actually like that slope, if each box is 1 unit, is roughly 1. So where would that be? This one should have been maybe down a little closer to 1. So maybe I'm a little bit steep. Like I said, I really just want rough shape. So I don't really care if your y values are right, as long as you're getting the positive and negative and 0 right, and when they're getting bigger versus getting smaller. But if you're getting really stuck, you can always go back and draw a tangent line and at least make broad statements for yourself of my tangent line has a shallow negative slope or a steep positive slope, things like that. Okay, plenty of time on that first one. Let's go ahead and work through the rest of these, hopefully not quite so slow. For this next one, I don't see any discontinuities. I do see a horizontal asymptote, I think. That's not a discontinuity. That's a global behavior. That means as x gets really, really big, y is approaching 0. It looks like I have a horizontal asymptote at 0. So I don't see anywhere that I have a perfectly horizontal tangent line, but they are going to get flatter and flatter as I go. So this is actually maybe simpler than the last one, except that I don't get those nice x-intercepts to get me started. What I can see here is that my slopes, no matter where I am, are going to be slightly negative. The further to the right I go, the closer those slopes get to 0. So y values are going to 0 as x gets big, so are slopes. That tangent line is just going to keep getting flatter and flatter and flatter. As I move to the left, what it looks like is happening is this function is concave up, so my slopes are just going to keep getting steeper. So the slopes are all negative, so I can draw negatives all the way across, which means that the entire graph should be below the x-axis. So again, these are slopes that I'm talking about up above becoming y values down below. Y values should all be negative because my slopes were all negative. I know that I want those slopes to be really close to 0 when x is big. So down here, my y's are really close to 0 when x is big. And I know that back over here on the left-hand side, I had steeper negative slopes, which means bigger negative numbers further from 0. So I maybe have a slope somewhere down here. And then as I move in, they're getting a little flatter. So I have a little bit less negative slope and a little bit less negative slope. So what we're getting actually almost just looks like a reflection of what we had up above. I'm just trying to make a nice curve because I was just guessing where those points were. But it should be something along these lines. It should also have a horizontal asymptote at x equals 0. Its y value should also get closer to 0 as we go because slopes up above were getting closer to 0. But its y value should all be negative because the slopes up above were all negative. So that's a rough sketch for that one. Okay, next page. These get interesting. We have some zeros again. So I look first for discontinuities and flat spots. I don't see any discontinuities, but I definitely have a flat spot and a flat spot. I have a lot of flat spots. This appears to be a sine wave of some sort. So every single one of those points should have a horizontal tangent associated with it, which means the slopes are 0. So at each of those points, f prime equals 0. 0, 0. Okay, so again, we're taking the slope and we're making it the y. In between those points, so here I can even write them in between. If you're having trouble looking at the original graph and trying to get this information as you sketch your new graph, that's why I write this little summary in between, is just to give you a chance to have that information without that original graph kind of making you want to copy. It's really easy to just start copying what you see up above. So if I start thinking tangent lines, what I see is that I would have negative tangent lines on the far left, and then they would switch to negative slopes, negative, positive, negative, and again, I'm talking slope, positive, negative. So we're going to have this alternating pattern where we have, let's see, positive, positive, positive. I don't remember what colors I did up above. Sorry if I'm flip-flopping it. Negative, negative, negative. And really, we could just kind of go for it right now. There is a lot of nice symmetry to this graph, so that'll help us a little bit. Again, if you get kind of stuck and you can't decide where to put your y values, you can somewhat estimate what a tangent line will look like. So right there, if I'm just counting boxes, it looks to me like I have a slope of about roughly 2 over 1 up 2, which would mean this one would be a slope of about negative 2. So if these are boxes, I think I'm seeing, and this one as well should be a negative 2. It looks like I should have biggest slope and smallest slope right in the middle. I don't care if you put these spot on at plus minus 2. I don't even know if I 100% believe my estimation. It's maybe more like 1.5. My line looks a little steep. But just to get you the idea, you can get some of these points, and recognizing that the maximum and minimum slope is going to be the same, that these lines should be, looks like parallel, that can be helpful. So basically, as I get into the details, I can say I start with a sort of steep negative slope, maybe like negative 2-ish, and then the slope gets smaller and smaller. Here the slope is 0. From there, I get a small positive slope. It gets bigger, maybe maxes out around 2. It gets smaller, and then 0. So as I'm connecting the dots, I should have negative slopes, and then they should start getting bigger and bigger. And then they hit 0. I get positive slopes. They get bigger. They max out, and then they have to get smaller again. The next section, I have small negative slopes. They get bigger. They come back to 0. So small negative y values, they get bigger. They come back to 0. And let's see, then we start repeating what we've been seeing. Small positive, bigger, 0. And we should just see this pattern repeat and repeat and repeat. And again, I'm not really worried about exactly how far up or down you go. But your zeros should be right. When your y values are positive or negative should be right. And catching on a little bit that those peaks should be all kind of at the same y value, I think that would be good for that one. Okay, next one has kind of a mix of the last two. I think I'll stick with purple at first. It does have a couple of flat spots, so I will start with those. There, the slope is 0, so when I move down to my Q prime graph, I'm going to have y-intercept. So this is a slope of 0, which becomes a y value of 0. All right, I notice that out here, my slopes are really close to 0, and that's true on the far right as well. So maybe I'll write a headed to 0 and a headed to 0 as we go those directions. And then in between, what can I say? These are definitely negative slopes as I come in. And then I switch to positive slopes. And then I switch back to negative slopes. So positive was only in the middle, and negative on the outsides. Okay, so that's what I have to work with. If I want to get into the details a little more, okay, so let's see. I need my slopes to be negative but really close to 0. So my y values should be negative but really close to 0. As I work my way to the right, they are getting more negative, steeper negative for a little while, and then they're going to switch to less negative and then 0. So I will, let's see, start really close to 0. They're going to get a little bit more negative, a little bit more, and then they have to come back to 0. And again, remember what I said originally was about slope, then I'm saying it about y. So that's not true. What I said is not true about the slopes of this pink section, this graph I'm drawing. It's the y values are very close to 0, but negative. They get more negative, and then they have to start getting less negative and come back to 0. For the middle section, my slopes become slightly positive, more positive. It looks like the steepest slope will be right about here in the middle, and then they start to get closer to 0 again, and then all the way back to 0. So my slopes are, my y values down below are slightly positive, a little more positive. The biggest one should happen right in the middle, and then they get less positive and come back down to 0. For this last section, I get slightly negative. So starting from 0, slightly negative, they get a little more negative. That's maybe the steepest right around there. And then they stay negative, but they start to get closer and closer to 0. So my y values need to become a little negative. They get a little bit more negative, but then they have to start coming back to 0 again. So the original function had a horizontal asymptote at y equals 0, and the new function does as well. And you'll find that in general, if your function has some sort of asymptotic behavior, its derivative will as well. It might not be the exact same asymptote, it might be in a different spot, but asymptotic behavior tends to show through as you're doing derivatives. The same was true in this one. We had a horizontal asymptote in the function, also a horizontal asymptote in the derivative. Okay, one last pair. I don't know that they're necessarily the trickiest, so if you haven't tried so far, now would be a great time to try graphing these yourself and then checking in. I see 2 flat spots, or what looks like they might be flat spots. So it looks to me like my slope is 0 there. I'm going to translate that down to my y value being 0 for the derivative. Okay, so about like that. Interestingly, in this one, the y values are not the y values, the slopes in between those points are all positive. So everything here is going to be positive, which means down below, other than those zeros, I expect all my y values to be positive. So I expect the entire graph to sit on that top half. Okay, so if I start to walk through some of the details, I start with a fairly steep, a big positive slope, and then those slopes are getting smaller until I hit 0. So I'm going to, this one's tricky because I have to do the opposite of the original graph, and our brains never want to do that. I'm going to start with a fairly big positive slope, and then they're positive but getting smaller, and eventually we have to hit 0 at the same x value as the flat spot. After that, my slopes become slightly positive and a little more positive, and right at x equals 0, looks like I'll have the steepest slope, and then they flatten out a little bit until we come back to 0. So that means that below, my y values need to switch right back. I'm going to round this out just a little so it doesn't look like a sharp corner, to being positive. And then they're going to get a little more positive. It looks like the biggest positive should have been at 0. And then they start to come back down to 0. All right, last segment, my slopes are 0 and then slightly positive and then more positive and more positive. So 0 to slightly positive to more positive and more positive. So roughly that sort of shape. Okay, last but not least, in some ways this one's actually really easy. I don't see anywhere that the slope is 0. I don't see any discontinuities. What I do see is that on the right-hand side, if the boxes are 1, the slope is always 1, right? So it's not even, is it positive or negative? I can be more exact. The slope is always 1 over here. Interestingly, it's always negative 1 over here. And I didn't really think through what my own question was there. I said there's no discontinuities, but there is a not differentiable. The function is not differentiable there, so the derivative will be undefined. The slope is undefined at x equals 0. Oops, I didn't write that all the way. Not just negative, but negative 1. Okay, so if we're imagining each of these boxes as 1 unit, we would say, okay, our slope is negative 1, and it's still 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 negative 1. So there's a line coming in here with the slope of negative 1 that just kind of needs to dead end and miss x equals 0. On the other side, we have the same thing happening, but it's coming in at positive 1. So coming in, coming in, coming in. And the way that you show that the derivative is undefined at 0 is by giving those open circles. So if you have a sharp corner or any kind of discontinuity, the derivative should only have open circles there. Otherwise, you're saying there is a value. So kind of an interesting graph because some of its pieces are really straightforward, but thinking through what happens in the middle is kind of interesting. So there's an abrupt jump in slopes when you cross over x equals 0. Okay, so hopefully that gives you a pretty good idea of some of the things that will come up. This one's definitely tricky, so give it your best attempt and then check in with me or bring questions to class and we can keep working on it. Thanks for watching.